Okay, we're looking at an expression that's given and we just want to simplify it. We're not asked to solve for anything because we don't have an equal sign. Remember, you can't solve for x if there's no equal sign. So in this case, we're just simplifying. So if I look at this, the first thing I can do to simplify is to use my distributive property. And this is probably what everyone was doing as they were going through the problem. At least I hope so. So when I distribute the 2 to everything, that's a positive 2 being distributed. So positive 2 times positive 4x gives me 8x. Positive 2 times positive 7 equals positive 14. This is where people will likely make mistakes. So if you are doing, this is essentially distributing a negative 3. That's how we can think of it. So I'm distributing a negative 3 to 2x, so that's going to make it minus 6x. And then when I distribute negative 3 to negative 4, which is again how I think you should be thinking about it, negative 3 times negative 4 equals positive 12. So if you did make a mistake, chances are that's a mistake you made. All right, or that could be the mistake you made, I'll just say that much. So 8x minus 6x is going to be 2x. So I'm just looking at my number or my variable terms right there. And then I can take my number terms right here. 14 plus 12 is 26. And there it is. So the answer is C. That's what most people were thinking, and that is indeed correct. So we are just going to get some practice today with volume of prisms. And like I said, there's actually no cylinders on our worksheet today. But what we're going to do is look at some that have a little bit more challenge to them. They're still prisms, so we're still using the same formula. The volume of a prism is the area of the base times the height, and I will use a capital B to represent the area of the base. So remember that formula that we learned on Friday is still the only one you need to know. We'll introduce another one tomorrow. Let me get out of this. So there's going to be a PDF in Canvas. All right, so if we look at this, I will start up here. First of all, let me zoom out so I can show you something that's important to know. On this, there's 2 pages you can see in this PDF. On the first page, do all the problems except the ones crossed out. That's pretty straightforward. On the second one, it's a little different. Only do the ones that have a red box around them. So just make sure you're clear on that. Besides that, let's do 2 of these problems. So I'm already giving you 2 of these problems answered and solved. So I highly recommend you guys keep track of this work that we're doing. And if you have any questions, you can refer back to us. If you want to get some paper out as we go through it, it is going to take me a second before we finish this up. So you can take the time to get some paper out real quick. And of course, the first question, now it's not really a question because it says it right here, but what kind of prism are we looking at? What kind of solid? It is a triangular prism. Notice this is called an equilateral triangular prism. You don't have to include that equilateral part right there, but that does help us to know that this is an equilateral triangle. All right, so if we're starting, how I always recommend we start, and maybe I'll kind of separate this into 2 different parts. So over here on the left is going to be my volume calculation, which is the area of the base times the height. Once I know it's a prism, then I can use that formula. There will be a different formula for other types of solids, but if it's a prism, that's my formula. So my question now is, are there any of these dimensions that we already know? Do we know the area of the base or do we know the height of the prism? We know where the base is. Do we actually know the area of the base? And I'll go ahead and say, typically the area of the base is something you have to solve for separately and then bring it into the equation. And that's going to be true here. So I guess the question is, what is the height of this prism? 10. And when you're thinking about the height of the prism, remember it has to be whatever is perpendicular to the base. So the base is this triangle right here. Imagine you could actually physically manipulate this prism and put it so the triangle is flat on the ground. At that point, the question is, what's coming perpendicular to the ground? What's coming straight up into the air? And the answer is it's that 10 centimeters. So this, if I draw this right angle right there, you can see that 10 represents the height of the prism. Okay, so I don't know the area of the base yet. I'll kind of leave that one blank, but I know the height of the prism is 10. So now I have to do a separate calculation, and this is how we approach volume problems. The separate calculation I need to do to find the area of the base, remember that's capital B, area of the base. This is a triangle. The side that I shaded right there, the face of this that I just shaded, is a triangle, so my formula is base times height divided by 2. And the base and the height that we're talking about here are different things. Now we're looking at this shape as though it's just a two-dimensional triangle, because that's what it is. So what is the base of the triangle and what's the height of the triangle? So do we know either one of those calculations or either one of those numbers? What is the base of this triangle going to be? Six. Okay, it just came in through the chat. There we are. So you can see right here, this 6 is the length of the base. The height, do we have that number given to us right now?
No.
Okay, we do not. And this is where, if people are doing this kind of problem, there is another one exactly like this. Well, different numbers, but the same concept. There is another one on this worksheet. So the mistake that you're most likely to make is to say, well, if this is 6, it's 6 all the way around this triangle, therefore the height is 6. But that's not true. Okay, so make sure we don't make this mistake. Because the height, let me clear this shading I did. The height here has to be perpendicular to the base. All of our dimensions always have to be perpendicular. If you can remember that rule, you're going to make very few mistakes. So to finish solving this, let me just kind of extract this base shape right here. So that's supposed to be an equilateral triangle that's 6 on each side with a line coming down and a right angle right there. And well, let me get thoughts on this initially. What do you guys think we need to do? Maybe just a first step, not the full process. There we go. That's the first step we can take. This bottom 6 right here, because this is an equilateral triangle, this doesn't work with every triangle, but because it's equilateral, or if it was isosceles, this would also be true. We can take this and we can split these into half of the 6. So that's going to be 3. Oops. That's going to be 3, and that's going to be 3. And these are centimeters, but I don't need to label the centimeters every single step. Okay, now if we focus on this triangle right here, can anyone tell me what kind of triangle that is? This is a 30, 60, 90 triangle. Whenever we introduced the whole idea of a 30, 60, 90 triangle, we introduced it by splitting an equilateral triangle in half. So that's what's going on right here. So if we look at this, let me just draw this triangle now a little separately. And you don't have to show this, much work when you're doing this on your own, but it's good to see it here. Now I can see that's 3, that's 6. And can anyone tell me what the long side right here is going to be? So the answer, as seen in the chat, is 5.2, and we can solve this a couple of different ways. You can use trigonometry, you can use special right triangle rules. And I'm not sure how you got the answer when you put it in. I'm not sure which method you chose, but I can ask this question real quick. If you chose to use special right triangle rules, what do you have to multiply 3 by to get the long leg? Square root of 3. So this is going to be 3 square root of 3. Now that, if you can remember it, is very fast. You don't need to deal with trigonometry at all. Now, special right triangle rules are only helpful if you know them. If you don't, then trigonometry is the way to go. We already said this is a 30, 60, 90 triangle, and we know that because the original equilateral triangle, seen right there, all sides of an equilateral triangle are 60 degrees. So we can kind of figure it out as we go. So at this point, just as an example, I could have done the tangent of 60 degrees equals the opposite over the adjacent. In this case, it would be our unknown x over 3. So that's how you could solve it with trigonometry. Either way, you are going to get the answer, as seen before. Instead of x, maybe I should put h for height, because that's what we're solving for. So the height here will be 5.2. And this is the case where you might want to keep more decimals in because we're not done with our problem. If you just round it off to 5.2, that's not a problem. But if you wanted to keep it a little more exact, it'd be 5.19 something. I don't remember the numbers. So your call. I'm really not going to be too picky about that. But this does preserve the precision until the very end. And we could potentially only round right at the very end. Well, let's go ahead and plug this number, whichever one we pick to use. I'll go ahead and say 5.2. Because that's the height of my triangle, or whichever one, I can go ahead and plug that into my area of the base formula. So you need to find a way of organizing your paper so that you don't get confused about what you're looking at. So that's why I kind of have it neatly organized. At least it's neat enough for me. So at this point, we can just go through, plug that into the calculator, and we can come up with the area of the base. All right, feel free to write that down on the screen whenever you've got the answer. All right, so we've got 15.6. We might be tempted at this point to say that's our final answer, but this is just the area of the base. 15.6 centimeters squared. And I'm putting a box around that, but that, maybe I shouldn't because it's not my final answer. I just want to draw attention to it. So if I get rid of these boxes real quick, this 15.6 is now the area of the base, and that can be plugged right into that original formula. So I'm kind of figuring out how to cascade this. As soon as I knew the height of the triangle, I could put it into my area formula. As soon as I knew the area of the base, I could plug it into my volume formula. As soon as I know the volume, that's what we're solving for. All right, so 15.6 times 10 gives us our final answer here of 156. And what's my unit? There it is, cubic centimeters. Volume has cubic units. If you had rounded this only at the very end, if you had kept this 5.19, then your answer would have been a little bit different. I think it's like 155.4. I could be off. It doesn't really matter. But you're off by just a little bit from this answer when you don't round until the very end. So I actually have an answer key here in the classroom, and I put both answers because for me, either one's acceptable. As long as you know the process, we're good to go. All right, any questions on this one? All right, let me go ahead and clear this, and we will look at one more practice problem. This is going to be on this page. Notice that I did include some things that are a little bit tricky. We've got what's called a composite solid. And maybe traditionally I would have waited a little bit longer before we saw these, but you can figure this out. And just as a general hint on this, and some of you don't even need any hints for it, but I want you to think about this as either, well, let's just look at it one way. You can look at this as two rectangular prisms that are shoved right next to each other. So if you can get the volume of each of those rectangular prisms and add them together, then you've got the total volume. So I'm not going to do that problem. Instead, I'm going to do this one over here, which is another composite solid. This will let me. Sometimes it lets me zoom in. It's not wanting to do that right now. Oh, there's a problem. All right. So let's look at this one right here. I've got two different solids that are shoved together. So the basic idea is this. If I can get the volume of this solid right here, and then add it to the volume of this solid down below, then I have the total volume. Okay, so I want to split this up into two different problems, first of all. I'm going to have the volume of one of my prisms. And because it's a prism, it's going to be the area of the base times the height. The other one is going to be another prism, which is the area of the base times the height. So what do we do? Which one do we want to start with, the top one or the bottom? The bottom one. The bottom one does look a little bit easier. Okay, so with the bottom one, let's see what we've got. What kind of prism is that? Rectangular prism. Now, keep in mind, because we name the prism based on its base shape, every side of this prism is a rectangle. So technically, any one of these faces can be the base. But to make it kind of consistent, I want to consider this face right here to be the base. So I know I kind of covered up the number. Let me show that a little differently, where I'm not covering up the number. So if that's the base of the base face of this rectangular prism, first of all, what's my area formula? Well, that would be the total volume. But we're just talking about a rectangle. What is our area formula for a rectangle? Length times width, yeah, and I'm just going to call it a little different. I'm going to call it base times height, but it's essentially the same thing. So for this particular face that we're calling the base, what's the length, or the base, what's the height?
centimeters of the height, 10 would be the base.
There it is. Notice 4 is the height of that face. If that's 10 right there, that's 10 right there, and it doesn't matter which side of that we call the base, but yeah, there it is. 10 times 4. So now the area of the base will be 40 centimeters squared. Now I can plug that right back into the formula. So the area of the base is 40. What's the height of this prism now? And to answer that, remember, if you took that base that we decided and you put it flat on the ground, what length would be going up into the air? What height would be going up into the air?
6.
6 would. So now we can just multiply that out. We get 240 centimeters cubed. So there's the the volume of the rectangular prism. Now we need to find the volume of our triangular prism. Well, I said it's a triangular prism, but hopefully you guys already saw that very clearly. And this one's going to get a little bit tricky because it doesn't look like we have everything that we need. Let me first of all, the area of the base down here. So it is a triangle. I think we can all agree to that. What is the area formula for a triangle? There it is, base times height divided by 2. And let's kind of figure out what we already know, and then we can figure out how this cascades. So when I say that, I want to make sure you understand what I mean. Do we know the area of the base right now? Or do we have to calculate that? Okay, so we do not know the area of the base. We can find it, but we don't know it right now. That's what I'm trying to get across with this. So that is something we have to calculate. But do I already know the height of my prism? What is the height of our prism? It's also 6. If I put that triangle so it was flat on the ground, then 6 is the length that would be going up into the air, 6 centimeters. So if I don't know the area of the base, that's what I have down here. That's what we're going to calculate. So in this formula, do I know the base length of my triangle?
Yeah.
What is the base length? We will do that, but for right now, the base, it represents the entire triangle. 10. Do we know the height? We don't know the height. Oh, I didn't mean to. So that's 10. Let me erase something real quick. Okay. So what we need to do, let's explain how this cascades. So the height of this is unknown, but if I knew the height, then let me do this in a different color. You can see what's going to happen. If I knew the height, I could take the height, I could plug it into that. And then I'd know the area of the base, and I could plug it into that formula. And once I know that, then I know the volume. So when I say this kind of cascades, we set up our formulas. Now we can actually do that. So the only thing I have left to do is figure out what's the height of my triangle. All right, I'll go ahead and leave that on there so we can kind of see what the flow of our problem is. Okay, I'm going to draw this triangle that forms a base right here. So these two sides are congruent and they're both 13. This is the height of it right here. And then the overall length is 10. So what can we do? What's our process going to be? Split that 10 in half. So I've got 5 and 5. So now if I draw this one triangle separately, this is 5, this is 13. That's a right triangle. Can I solve for the height? And how would I solve for the height? And let me go ahead and tell you real quick, this is not a 30, 60, 90 triangle. So we can't use special right triangle rules. So what can we do instead? There it is, Pythagorean theorem. If we know two sides, we can solve for the third. And we could have done Pythagorean theorem with that last example too, but special right triangles makes it a little bit faster. So with Pythagorean theorem, if we label our sides, we've got 5 squared plus h squared equals 13 squared. I'm just setting it up because you guys should know how to do Pythagorean theorem. And we know that the hypotenuse is going to be the longest side. So now you guys can solve for h. So I'll just put h equals right there, and you guys can solve for that. So with this, we now know the height of our triangle. So now let's kind of go through the cascade, see if it makes sense. So we got 12 centimeters is the height of the triangle. I want to plug that into this area formula. So now you can solve for the area of the base. So by plugging that in, we get 60 centimeters squared. And now this 60 centimeters squared is the area of the base, and that can be plugged in. So I'm just going to plug in the 60 right there. And now we can just do that quick calculation to figure out the volume of our prism. And you guys can plug that answer in pretty quickly, I bet. All right, 360 it is. What's a unit? Centimeters cubed. So, and I mean, yeah, we have two of the same answers. So I'll just take that. Now we're not done at this point, but luckily we've done all the hard part, because the volume of this entire shape is going to be the volume of our triangular prism plus the volume of our rectangular prism. That'll be the total volume. So we've got both of those numbers. It's pretty straightforward. For the triangular prism, it's 360. For the rectangular prism, it's 240. Add that up, and we get our total volume. Perfect. 600 centimeters cubed. Okay, and I'll put kind of a double box around that because I was putting boxes around our two volumes, but now this is our real final answer. Sure, that looked like a bit of work, but it won't take you guys 20 minutes to do that if you know what you're doing. It might take you a couple of minutes as you work through the different steps. It just took me a long time because I was explaining every single thing I was doing. So if that is making sense to you, then you should be good to go with most of these problems. There might be a question or two that stump you. Feel free to take a picture of this before I erase it in about 5 seconds. Okay. So if I zoom back out and zoom out here, you will see that there will be some problems that require trigonometry. Like right here, this one has a 70-degree angle. That's not a special right triangle. We will have to use trigonometry. We've got special right triangle rules that are coming into play. So my point is, if you come across a problem that is really challenging to you, maybe you don't know how to solve it, you can give it your best shot, and then you can bring that back to class tomorrow for, get those questions answered, figure out what's going on. But if you get it all figured out, you get all the right answers, at least you feel what's correct, that's really good. And with that, I've basically set you up for today. We already did 2 of the 11 problems, so you only have 9 more to go. So have a wonderful day. If you have any questions on this or any past assignments, feel free to stick around. Otherwise, you can log off and have a great day. I will see you tomorrow.